Morning, everybody. Thank you for making the trek all the way over to Mandalay Bay. I know it's a little far away from everywhere else on the Strip. So I have two great speakers here with me today. I have Adrian Simonson from the NOAA Open Data Dissemination Program and Brendan Riley from OS Climate. And we're going to talk to you about open data for impact. This is how to use open data to quantify and manage climate-related risks. So a little bit of housekeeping before we start. If you can, please turn off your phone or silent your phone. If you do need to make a call, please step outside. I have super cool stickers, holographic stickers, so if you hang around to the end, I'll pass those out. It's the sticker is the image that you see up there. Back up one. And please fill out the survey. So the surveys are really important to us. And we will end with a QR code, and that will link you to all the information that we present here today, so you don't have to try and capture the URLs or whatever with your phone. All right, so let's get started. So open data for impact, and how to use open data to quantify and manage climate risk. So Adrian, who will speak first after me, she is going to speak as an open data producer or producer of open data, putting data into the open data program. And Brendan will speak as an open data consumer or someone who's using data that's in the program. And I'll talk a little bit about what the program is and how that works as well. So climate-related risks, what do we mean by that? Well, the Earth is getting hotter due to human activity. And as the Earth gets hotter, we get more extreme weather. Drier summers mean more wildfires. Glaciers are melting. Climate change is real. And this impacts a variety of factors like sea level, salinity, the salt that's in the ocean, and temperature, amongst other things. And risks like sea level rise mean that flooding and coastal erosion happen more often than they did before. But what if we could measure risk using climate data that we gather from a variety of sources? So we gather climate-related data from satellites like the NOAA GOES constellation, which images the planet every day. Ground radar stations like NOAA NEXRAD, which is a network of 160 high-resolution S-band Doppler weather radars. And we also get data from weather buoys at sea, although I think that's a sea lion. I don't think he's actually helping gather any climate data. He's just hitching a ride. So what does the data tell us? Well, I mean, you use climate data every day. Do I need to bring the umbrella? Is it going to rain today? And that's measuring your risk, right? Because, of course, climate data is used to determine your local forecast. But if we think broader, imagine managing risk and impact at a state or regional or even global level. We can also use climate data for disaster response, like where to send help when there's a wildfire. So this is the California Camp Fire, which is one of the deadliest fires in California history. You can see the fire start suddenly, and then it just engulfs the town and everything near it. Now, CAL FIRE knew that there was a fire up in the foothills. What they didn't know was how rapidly it was spreading, because they couldn't send a human up there to actually get close enough to the fire and see it as it hopped from hill to hill. It was a very windy day. And they weren't aware of just how arid and dry the brush was, so it just decimated that entire town. In this scenario, we could have actually used data we get from satellites on orbit to alert emergency responders, not just that there is a fire, but how rapidly it's growing. And that, again, can be hard to see from the ground. In this case, they couldn't actually drive a truck up to see the fire. It was in a valley on the other side of a hill. Okay, so we have all this data, and we have climate risk that we're trying to manage. You may be thinking, hey, I want to help solve climate change. I hope you do, actually. Or maybe you want to gauge your company's climate risk. Brendan's actually going to talk a little bit about climate risk during his talk. So what if we made all these high-value data sets, the satellite data, the ground radar station data, weather buoy data, data we get from drones, what if we made all of this open to the public? Well, and open to anyone, so you could use this data to help solve climate change or assess your risk. But we did that. We started on this process 10 years ago, and now we have over 100 petabytes of data in the AWS Open Data program. And it is open to the public. You don't even need an AWS account to access the data and use it. And at the end of the talk today, I'll even show you how you can use the data using a Jupyter notebook and get started and see what you can do. It's a great way to get started with the data, figure out how to use it using some Bot03 Python libraries. All right, so I'm happy to have Adrian Simonson from the NOAA Open Data Dissemination Program here today to tell you about NOAA's cloud journey and as an open data provider. I'll hand it over to Adrian.
Thank you, Chris. Good morning, everyone. Thank you, Chris. It's a pleasure to be here. I'd like to begin by acknowledging and thanking the small and unique interdisciplinary team that made today's presentation and NOAA itself possible. Now, to the moving image on the title slide, which reflects climate model surface temperature change, the data shows projected changes in surface temperature based on the Intergovernmental Panel on Climate Change's most optimistic future scenario, SSP1, where carbon dioxide emissions continue around current levels until 2050, then decrease but do not reach net zero by 2100. In this scenario, extreme weather is common, but the world would have dodged the worst impacts of climate change. Equity in NOAA data access is critical to help achieve this outcome. NOAA is an agency under the Department of Commerce. The department's mission is to create the conditions for economic growth and opportunity. NOAA's mission is to understand and predict changes in climate, weather, ocean, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. In order to accomplish its mission and support the department's mission, NOAA provides daily weather forecasts, severe storm warnings, and climate monitoring, and supports fisheries management, coastal restoration, and marine commerce, to name just a few of some of NOAA's responsibilities. NOAA's products and services support economic vitality and affect more than 1/3 of America's gross domestic product. NOAA Open Data Dissemination, or NOD, is an enterprise service that supports the NOAA line offices, such as the National Weather Service or the National Marine Fisheries Service, to provide their open data to the public via 3 cloud service providers with no egress costs for the user or the agency. As a result, NOD is able to make NOAA data on the cloud easy to find and use, which in turn supports the administration's priorities to build a climate-ready nation, make equity central to NOAA's mission, and accelerate growth in an information-based blue economy. When NOAA first started down this path, the agency was concerned about the exponentially increasing volumes of data collected, stewarded, and archived, as well as the exponentially increasing public demand for NOAA data. The timing was right. In support of the nation, NOAA collects, creates, archives, and distributes hundreds of thousands of data sets, but major obstacles to the effective public use of NOAA's data, including the costs and secondary challenges associated with increasing volume, cybersecurity concerns, and bandwidth limitations, have inadvertently limited user access. NOAA was focused on reducing stress on its on-premise dissemination systems and improving services for users. The timing was right, as the Cloud Service Provider, or CSP, technical capabilities had matured enough to address data growth and management challenges. Excuse me. As a result, NOD is able to make NOAA data on the cloud easy to find and use, which supports governmental mandates, including the Federal Data Strategy and the Evidence Act, to provide open data to the public. And by making NOAA data easier to find and use, NOD democratizes data accessibility and enables innovation. A recurring timeline will be helpful in understanding how the Big Data Project, or BDP, which began in April 2015, became NOAA Open Data Dissemination, or NOD. After a formal process, NOAA signed 3-year, non-competitive, cooperative research and development agreements, or CRADAs, with 5 partners in 2015. The CRADA phase resulted in more than 150 data sets via the cloud, including NexRAD Next Generation Radar. Providing NexRAD data on the cloud resulted in new and novel applications of the data, which was only feasible because the entire period of record for NexRAD products could be accessed at once. Requesting and manipulating this data before NOD simply wasn't feasible, as the data was on tape. The CRADAs were then extended for a single year. You're asking, what is a CRADA? How can you get in on this type of effort? The Cooperative Research and Development Agreement, or CRADA, is a written agreement between a private US company, university, or other entity and NOAA. CRADAs are also one of the easiest and most flexible agreements for organizations working with NOAA. The Big Data Project CRADAs began with a formal process requesting information from industry. The CRADA allows NOAA and non-federal partners to maximize their resources by sharing technical expertise in an environment where intellectual property emerging from the effort is protected, and the partner is encouraged to commercialize the results of the activity. The CRADA is based on a pre-approved legal template, which is designed to speed the time for approval of the agreement within NOAA. Under a CRADA, NOAA may contribute staff, facilities, expertise, and intellectual property to a collaboration, but not funding. The CRADA partner or partners may contribute any of the above, but may also contribute funding to the agreement. Thus, CRADAs were a low-risk mechanism for creating and testing a smaller version of the full market ecosystem, providing an iterative approach to dissemination without disrupting NOAA operations and allowing for lessons learned and real-time modifications to the dissemination process. The goal of the CRADA was to make NOAA data publicly available at no net cost to NOAA or the public, and that includes users of the data, i.e. free egress. NOAA learned a great deal from the CRADAs. Today we'll focus on a few relevant lessons. Access on cloud platforms resulted in increased usage of NOAA data. Integration of NOAA data into industry tools is most effective. And NOAA learned that the key NOAA asset is the expertise to understand and support the data, not the data itself. This is because the data had been open and available before NOD, even if difficult to find and use. At the start of the project, it was unclear how the specifics of the effort might work, so a spiral development approach was adopted, allowing provisioning and transfer mechanisms, dataset richness, period of record, and data complexity, for example, to evolve over time. We also heard from, this led directly to the adoption of a data broker to facilitate data transfers, cloud mechanics, and be a source of experimental infrastructure needs, as well as support user engagement. I'm sorry, I think I may have skipped a slide. Nope, my apologies, folks. So this led directly to the adoption of a data broker to facilitate data transfers, cloud mechanics, and be a source of experimental infrastructure needs, as well as support user engagement to understand user needs. We also heard from users unwilling to take a chance on an experimental dissemination method, as well as from internal NOAA that contracts were needed to provide certainty for both users and NOAA that the data will continue to be provided. So let's talk a little bit about the architecture for both BDP and NOD. Obviously, they're the same. On the left side, there are pictures representing the data NOAA collects and the observing platforms by which it collects that data, all within the federal security boundary. Follow the arrow to the right to find the NOAA Cooperative Institute of Satellite Earth System Studies, or SES, NOD's trusted data broker. SES is allowed inside NOAA's security boundary to retrieve data sets, which it then transmits to the CSPs, including the AWS Registry of Open Data Programs, or RODA, and other public cloud programs, which in turn provide the data to an exponential number of users, enabling their innovative data analysis and decision-making. SES is perfectly positioned to act as data broker and provide NOAA with flexibility, agility, and innovation in developing the R&D technical processes and other elements of the program, while still providing data sets operationally. This is critical, since each data set is different, as is each LO and each cloud service provider. In addition, SES manages the resource and access controls for the NOD holdings on the CSPs. Given that the data buckets are outside the NOAA FISMA or federal security boundary, a third party like SES must own the data buckets. The data broker monitors data flows from source to destination, resolves operational problems, supports the development of metrics, and helps to develop and implement approaches to ensure end-to-end data integrity. The data broker certifies select CSP holdings as authoritative NOAA data, and in many cases backfills near real-time cloud holdings with the complete period of record for select data sets from NOAA archives. There are significant challenges to the adoption of new paradigms within the federal government, including the transition to cloud. It was clear that cloud access to copies of NOAA's data was a technically feasible endeavor. However, NOD also had to overcome economic and cultural challenges, which required a time-consuming effort based largely on interpersonal relationships. These challenges, however, provide opportunities for improved data, technical, and analytics capabilities for users. NOD is working to understand user information needs through engagement and feedback. Some of those challenges and opportunities, as you can see, format conversions, cloud-based tools, data quality, data provenance, interoperability across disciplines, understanding user needs, and understanding and communicating the value of the data and how to use it. Very critical. There's so much to the NOD origin story. We were asked to write about it in a chapter for Big Data Analytics in Earth, Atmospheric, and Ocean Sciences, edited by Thomas Wong, Tiffany Vance, and Christopher Lin, published by Wiley and available now. The chapter provides more in-depth information than we have time for today. There will be a QR code for the book at the end of the slideshow. I just have to say, I got mine right before Thanksgiving, and it is awesome. Hats off to the editors. They're amazing. So back to our timeline. In 2019, NOAA formally requested proposals from industry, which ultimately resulted in 3 signed contracts with our current cloud service providers, including Amazon Web Services, by the last quarter of that year. This resulted in the Big Data Project becoming the Big Data Program, and initial BDP operational capability began in October 2019. NOD leverages the cloud service provider's expertise, platforms, and tools by a very, very, very low-cost 10-year contracts, which in essence represent revolutionary public-private partnerships that have democratized NOAA data dissemination via the cloud. These contracts have a base of 2 years with 4 options of 2 years each for a total of 10 years. October 1st, 2022 was the start of the 4th year of the contracts. The contracts provide for a minimum of 5 petabytes of NOAA's open environmental data on each CSP. These 5 petabytes are determined by NOAA. However, users can also request data sets via their CSP, or the CSPs may request data themselves, neither of which counts against the NOAA allocation. In addition, any LO or line office that's part of NOAA that signs a separate storage and compute contract with one of the 3 NOD cloud service providers is guaranteed free public egress for that data. The contracts provided needed certainty for all parties, including the users relying on NOAA data, the cloud service providers themselves, as well as NOAA, who relies on these partnerships to provide the public access to NOAA data on an operational basis. As a result, NOD reduces and removes obstacles to the public use of data while avoiding the costs and risks associated with federal data access services. Peak loads that could take NOAA on-premise servers down is just another day for the CSPs, thus improving use and usability for a growing cloud community. NOD is one of NOAA's forerunner activities associated with NOAA's broader transition to the cloud. The new name was approved by Congress in the fiscal 22 Consolidated Appropriations Act with the direction to, quote, improve public access to climate change data, excuse me, and to transition NOAA data to the cloud, close quote. NOD is an enterprise program listed in the Operational Excellence and Mission Success section of the fiscal 2022 through 2026 NOAA Strategic Plan, released July 11th, supporting the NOAA priorities outlined earlier in the presentation. And the fiscal 23 House Commerce, Justice, Science, and Related Agencies Explanatory Statement, referred to as the House Mark, provides $3.3 million for NOD in support of Climate Ready Nation and NOAA's role in implementing the Executive Order 14008, tackling the climate crisis at home and abroad. And we're very much hoping that the upcoming omnibus that hopefully will happen in December will actually include this funding for NOD. So one final visit to our timeline where we see that as a result of congressional approval, the timeline now includes NOD's new name and status as a NOAA-wide enterprise service. The timeline reveals how NOD has evolved over the years from a CRADA into initial operating status, and finally into an enterprise service that provides NOAA's open data to the public via the cloud service providers. NOD datasets are from across NOAA and include near real-time datasets that can support user operations, period of record for select datasets, and weather, atmospheric, climate, oceanographic, fisheries, and emergency response imagery, including satellite, radar, and model data, forecast products, and surface observations. A full list is available on the NOD website, listed here on the bottom right, along with direct links to the landing pages. The link to RODA is also listed. The bar chart at the bottom reflects that the total volume of data available via NOD by the end of fiscal 2022 was 24 petabytes, revealing fast, significant growth in the volume of NOAA data on the cloud. User interest is increasing commensurately. NOD has about 12 petabytes of NOAA data on AWS RODA, which provides the public with free access to the data and free egress. AWS supports a higher volume of traffic than NOAA can on its on-premise systems because industry's expertise with the infrastructure as a service platform cannot be replicated via governmental funding. Instead, NOAA leverages this capability for users. Let's talk for a minute about what interactions and accessions can tell us about the use of NOAA data on NOD. AWS supports a high volume of traffic for interactions. To reflect the number of touch points a user has with NOAA data, we use the term interactions. Interactions can include accessing the metadata, for example. One user may interact many times with a single data set. AWS supported sustained interactions with NOAA near real-time data of 1.2 to 1.5 billion per day, interactions per day, for 28 days straight. To understand how much data is accessed, we use the term accession. NOD has supported accession to 1.2 petabytes of data in a single day without any throttling of the data or negative impacts to other users. Both of these results would be nearly impossible, if not actually impossible, with NOAA's current on-premise access capabilities. I also want to draw your attention to the pie chart on the right. In the month of September 2022, we created a breakdown of user interactions of NOAA data on AWS by source. In examining user interactions, we see that more than half of the users are using AWS to interact with NOD data, whereas the remaining 44% are accessing NOAA data on AWS from other sources and egressing the data. Not everyone is in the cloud yet. The advantage to using the data where it resides is the convenience of locating the compute capability next to the data storage in the cloud, as well as the unique analytic and tools provided. As users get more cloud savvy, we expect the cloud access to grow. NOAA has a wide range of data available, and this data is used for more than just weather forecasting. It's used to mitigate risk. So these images reflect a variety of environmental challenges. We have algal bloom on the far left, drought in the middle, and on the right is the 2013 Rim fire in particular. Then on the bottom left, we have an image reflecting, relating to climate risk assessment. In the middle, tornado forecasting, and the far right, coral bleaching. NOAA data helps us to understand both episodic and chronic environmental disasters and their projected impacts, thus supporting the deployment of public and private resources. NOD's revolutionary approach supports users building innovation and climate tech solutions via the cloud. Let me introduce you to a couple of them. Oh, I went the wrong way. Zeus AI is a startup founded this year. Did I do that right? Yeah, my apologies. Zeus AI is a startup founded this year using satellite imagery to provide real-time weather information to their customers. Zeus AI received a NASA Small Business Innovation Research, or SBIR, award to predict 3D atmospheric structure from geostationary satellites using machine learning and artificial intelligence. This product improves wind forecasting, which can be seen in the background of the slide. Zeus uses geostationary operational environmental satellite, or GOES-R Level 1, multispectral satellite data, and high-resolution rapid refresh, or HRRR data, for their products accessed through Nod on AWS. Zeus AI is addressing current observing system gaps by using AI to fuse geostationary satellite imagery with weather forecasts. This technology provides the accuracy of high-resolution models with a fraction of the computational cost, lower latency, and improved refresh rates. Kate Duffy, co-founder of Zeus AI, shared that Nod makes it possible for us at Zeus AI to work with the big data needed for AI modeling. Circle Solutions is an AI-based company that provides energy forecasting solutions, including nodal, regional, and system-wide wind and solar power forecasts across the US. Co-founded by Daniel Vassallo and Thomas Sherman, who were named 2022 Forbes 30 Under 30 class, Circle provides wind and solar forecasts down to the turbine and farm level, respectively, to those participating in wholesale markets. Circle's analytics help balance the supply and demand side of energy. Circle accesses high-resolution rapid refresh, or HRRR, in two separate ways. Circle pulls the near real-time data through NOAA's NOMADS environment, which is an on-premise National Weather Service dissemination node, but accesses the historical HRRR data via Nod on AWS. All data and conversions are completed within Circle's own cloud environment, and Circle says NOAA is its most important partner for providing information to the energy industry. Nod accelerates open science by providing open data and open access to environmental data, research products, and results, and provisions new data for reproducibility, ensuring an open scientific process and reusable analytics pipelines. This transparency makes the data seeable, viewable, and understandable. And this approach incorporates the fair data principles of findability, accessibility, interoperability, and reuse of digital assets. In addition, Nod relies on and incorporates open source and source available software, such as Apache NiFi and Elasticsearch. Interoperability of diverse data sets is key to supporting users and driving innovation. Cloud-optimized data formats make the data more accessible in a performant manner, saving researchers and private enterprise time and money on compute costs. Nod supports and advances dataset interoperability by working with AWS RODA and other partners to develop a consistent and centralized location of information with documentation on the cloud. It is this centralized data in the cloud that enables users to leverage cloud tools, scalability, and processing. Then Nod's data broker establishes research and development pathways for format conversions, and AWS provides platform credits to allow for the conversion of the NOAA native formats into cloud-optimized data formats by users or other partners. The converted data sets are then made available on Nod. Stakeholder communities are forming around the conversion tools, further enabling innovation and advancing interoperability. Because Nod links users with NOAA data curation services, like NOAA's Archive, the National Centers for Environmental Information pictured here, that ensure well-organized, high-quality data, the CSPs and users can trust in that curation and spend their labor further down the data value chain, unleashing new economic potential. In effect, NOAA has created the Nod ecosystem, which utilizes the synergy and unique partnerships between NOAA, its cloud service providers, its users, and the community that is collaborating on NOAA data in the cloud. Nod democratizes public access to NOAA data via public-private partnerships, serves as an organizing function for a series of data collaboratives, communities of practice, and private companies seeking to create new information and products, leverages the CSP platforms and tools to improve user services and reduce dissemination costs, and spurs research and innovation on societal challenges like equity and climate change. Nod users take advantage of the cloud as a launchpad, accelerate demand for NOAA data, form consortiums, collaborate on cloud optimization, and challenge NOAA and the CSPs to provide data that is easier to access and use. The cloud service providers provide custom tools, support collaborative efforts with credits and other assistance, and enable dataset integration across the federal government and beyond. There's clear and compelling synergy between NOAA's mission, the CSP's commercial goals, and user requirements. NOAA is leveraging AWS's integration talents and tools to support NOAA's mission in much the same way that AWS is leveraging NOAA's data and expertise to support its missions. As a result, NOAA and its data users can trust that AWS will promote and support the development of interoperable formats precisely because the formats are innate to AWS's optimized cloud architecture. The NOD ecosystem also works closely within NOAA to anticipate the needs of external users. Given the reInvent audience, we thought many of you might be interested in the NOAA Small Business Innovation Research, or SBIR program, which provides grant funding for small businesses to conduct research and development towards innovative products or services with strong commercial potential. The annual competition looks for proposals for innovative ideas relevant to the NOAA mission, and proposals using NOAA data to solve problems in the NOAA mission are highly desirable. The program is organized into 2 phases, with phase 1 supporting feasibility studies for 6 months and up to $150K, and phase 2 supporting further research and development for up to 2 years and $500,000. Questions about the program can also be directed to noaa.sbir@noaa.gov, and there will be a QR code at the end of the presentation. So finally, NOD is engaging the external user community to support user needs and to help build a climate-ready nation. NOD would like to hear from you about your innovation use case, your innovative use case, and garner your feedback on NOAA data via the cloud. So I have an ask for the audience. Do you have a preference on data formats? Do you have an innovative use case you're willing to share via blog post or other medium? If you're using our data, please let us know by emailing the NOD team at nod@noaa.gov. Let NOD know how to help you. What NOAA data do you want to see in the cloud? That's the end. This concludes my presentation, and for now, I'm going to turn over the mic to Brendan Riley from OS Climate. Thank you so much.
Thank you. Good morning, I'm Brendan Riley. I'm from OS Climate. So OS Climate is part of the Linux Foundation. It's actually a free and open source organization that's funded by a consortium of organizations like Google, Amazon. Amazon is one of our biggest providers, and they give us a grant for our cloud services. Our mission is to provide open access to the data and analytics tools needed to analyze climate risk and to, most importantly, develop mitigation strategies from that data. So to do this, OS Climate actually collects, aligns, and tracks all of the data that we can that's climate related. And what that means is that we take all the data and we align it to the Paris Agreement. If you're not familiar, the Paris Agreement's a legally binding international treaty that was signed by 196 parties at COP21 in Paris in 2015. And what it did is it established the goal to limit global warming to well below 2 degrees and preferably 1.5 degrees Celsius by 2100. Compared to pre-industrial levels. Unfortunately, under our current policies, we are now on track for 2.7 degrees. I was in COP in Egypt over the last 2 weeks, and that's the number today, 2.7 degrees. Currently, there were 50,000 people who showed up from all over the world. Currently, these organizations are very focused on working together to try and find ways and set new policies to lower that trajectory. The question is it too late? The question I have is what policies will need to be implemented and how will those policies affect everybody in our society, and will those policies be extreme? The challenge is how to identify where the risks are coming from and how those risks will impact you, everyone in this room, the assets that you own, our country, our society, and how it's going to impact you in everyday life. First, what I want to do is explain what I mean by climate risk. Climate risk includes a lot more than just the climate. Most people think of it as the changing in our atmosphere and the changing in our weather. and the physical risks that are caused by climate change, like increased flooding, drought, heat stress, wildfires, sea level rise, and more. The fact is, physical climate risk represents just a fraction of the impact that everyone on this planet will feel that's related to climate change. At OS Climate, we view the risks associated with climate change at much more transition risk, social risk, economic risk, and policy risk. And those come from the transition to a low carbon world and the policies to try and mitigate the changes that will go on if we don't hit a 1.5 or a 2 degree world. So let me explain what I mean in things like policy risk. President Biden set a policy to have a zero carbon grid by 2035 in the United States. Sounds great, absolutely fantastic. But today, 56% of all the power generated in the US comes from carbon emitting sources, petroleum, gas, coal. And according to the Institute for Energy Research, to upgrade our grid in the United States will cost $5.7 trillion by 2040. That equates to $2,000 per household for every year between now and 2040. What that is it will increase your electric cost. Consumer electric costs, based on conservative estimates, will go up between 300 and 400% as we transition from coal to renewables. But we're going to do it very quickly, so it's going to cost a lot of money. That presents economic risk, and it'll also present social risks. To be clear, the impact of these policies will not be equitable, right? Lower income communities and individuals who spend a much greater percentage of their income on heating their house and keeping the lights on will be impacted greatly by this. So what OS Climate does is we're trying to track not only what the climate will do, but also what policies are being implemented, and trying to put all of the data together so that we can inform policymakers based on data the impacts of those policies in the long term so that they can actually be much more and better informed. So the risk of our grid going up and your electricity costs going up is one thing, but to put things on a much larger scale, I like to give you Nigeria's story, and I'm going to hit on this a couple times today. 90% of Nigeria's exports come from oil. Right? The country uses those exports to get dollars. They use the dollars to buy wheat and grain and infrastructure components to keep the country together, basically. They've got 120 million people. As we transition to a low carbon world, we will transition off of oil. And how does Nigeria survive this transition? That's climate risk. And what we do at OS Climate is we believe that the answer is in the data, right? So how we measure it is in a way that we use a lot of collaboration. We work with NOAA data and everybody else's. We use trusted sources. We use consensus, and we use a lot of math, right? The global collaboration effort led by organizations like NOAA help us to understand the possible physical risks, but again, it's a lot more than physical risks. So what happens is there's a global community also of economists that have built these integrated assessment models, or IAMs. And they actually are socioeconomic pathways that actually look at what the world will look like in a 2 degree world, a 3 degree world, a 4 degree world. And they provide these pathways. These organizations include folks like the UN, IPCC, NGFS, IEA, the Bank of England is doing stress tests with this. And what we at OS Climate are doing is We're aligning this data, the climate data and the transition data, to help identify what the world will look like, and to try and answer questions like, how can Nigeria transition, right? The fact is, again, the answer is in the data. Altogether, there's thousands of organizations focusing on this issue, and it's become the #1 priority of the world today. To answer these complex climate-related questions takes tons of collaboration, and in fact, I speak at a lot of places. The collaboration is, we are an open source community. We are part of the Linux Foundation, and Linux was built through the collaboration of tens of thousands of developers. So at the end, I will ask for your support in trying to actually get involved in doing this. But I want to explain a little bit more on what we do. So let me focus first on how OS Climate leverages NOAA data. So NOAA is one of 30 plus, it's actually 48 climate organizations that have run these massive climate models with supercomputers that align with the IPCC. In addition, so NASA, the Beijing Climate Center, the Canadian Center for Climate Modeling, the European Space Agency, Oxford, and other, and they've run these models and they've put them out, and they basically align all of this data to what's called a representative concentration pathway, how much carbon is in the atmosphere, and how much carbon will actually present what the temperature rise will be, or the global mean temperature. So more simply put, we take NOAA open source data, we downscale it, we map it to the entire world, and then we actually align it with these, what you see, RCPs, which is what the socioeconomic groups are doing, which is basically a global mean temperature range, right? Then we map it to every corner of the planet. The data's mapped entirely. We actually map it down to 5 square meters. For flood risk, we map it to full city range or country range for GDP and other factors. And we do it not from one model, we do it against all 48 models. We actually believe that every single one of them is wrong, because how do you actually predict what's going to happen in 2050 or 2070 or 2100? But collectively, we actually run Monte Carlo simulations and we do probability distributions on all of this to try and understand what is the probability of these risks happening over time. So we collect and align all of this data, right, from the transition scenarios and the physical risk scenarios, so that we can understand what sea level rise in Boston might look like in 2050. But at the same time, what will the GDP or unemployment rate or long-term interest rates be if we're at a 3-degree world that drove sea level rise to be at a high level, right? So ultimately, that allows us to do that globally and pinpoint at every place on the earth, in Nigeria, in Boston, actually down to your house, at 5 square meters, that it could be susceptible to flooding. And if it is, in 2050, what is the GDP? What will your interest rates be? What will society look like all over the world, so that we can actually understand the factors? So why do we do this? We're actually looking for ways to understand what the future looks like and to start mitigating all of this. We're building a data public utility. It's data commons. At the end, I'll actually show you the tools that different organizations within OS Climate are building. But this data public utility is making all of this data accessible via API to the world, to regulators, to policymakers, to insurance companies, to anybody that wants to take it free and open from OS Climate to try and understand risks and to calculate the overall impacts that they can have, so you can create mitigation strategies. To do this, We've mapped, 20 physical models, transition risks, thousands of them. So if you look at this, we go from 1850 historically to 2100. If you take the 40 climate models and the 70 IAMs, and each one of them have over 1,000 factors, we end up with billions and billions and billions of data points. But if you pick one location on the planet or one asset type, you end up with about 3 million different possible scenarios of what can happen over time. So we're in Vegas. So I said we run these Monte Carlo simulations on all of this. And when you start looking at it and saying, if I own a vineyard in Northern California, and I know it's going to get hotter, and I know there's going to be increased forest fires, and I know that there's going to be water stress, and I know lots of other factors, what do I do today? What do I do, right? So that is very localized. So what do you do if you are the president of Nigeria today? So the fact is that all of these components are actually causal in nature. They all affect everything. When you set a policy, because you know it's going to be drier or there's going to be water stress, there is ramifications on all of it. So back to this, so if you did know that all of those factors were going to happen, and you ran 3 million scenarios, and in 80% of those scenarios, things didn't look good, would you in Vegas take that bet, right? What would you would definitely not, right? So all of this is risks and probabilities and understanding the data, right? And not just understanding the data, understanding how this will unfold over time. Because we're talking about climate risks that will happen in 2030 and 2040 and 2050, 2070. So, however, if you know that something's going to happen by 2070, the assets are impaired today. You have to be taking actions today to try and mitigate those risks that will occur tomorrow. So, I want to give you a little bit more in depth on how we look at things. So NOAA talked about the data and everything else, but I say causal effects. I'm going to give you two stories. One is, everybody knows El Nino, right? So there's something called the Indian Ocean Dipole. So there are these climate modulators that drive the planet's climate. And the Indian Ocean Dipole is one, and when it's pronounced, it actually takes moisture out of the air over Australia, takes it and dumps it into Eastern Africa, right? Here's the causal effect of that. In 2019 and 2020, 10 million hectares of land burned. Everybody saw it on the news, right? But it also killed 1 billion animals and caused a decline in the GDP of Australia of 1.9%. It increased the lumber commodity price in the world by 11%, right? It actually displaced 3 million people. Everybody knows about Pakistan today, right? So other climate modulators have actually destroyed, what is it, 30% of Pakistan was flooded this year. 33 million people were displaced, right? It reduced the GDP by 3.8%, and it's profound. The gross domestic product was $21 billion was lost from flooding. And now you have mass migration. So the question is, if you know that the weather is going to be more pronounced and you can map that out, you actually have to understand what that does to society. And so that's what we're doing as an organization. But you also have to understand, if we don't hit 1.5 and it's 2 or 2.5 degrees, what does every half a degree that we miss the target cost, right? So population exposed to water scarcity, a half a degree increase is 2x, twice as many people, right? And you can see these numbers, and this is just 1.5 to 2. I said we were on a 2.7 degree pathway today, right? So it's fairly stark. At OS Climate, what we're trying to do is take all of that data, and we're building numerous products, tools, algorithms, through these collaborations and making them available to everybody. So I'll walk through some of them. So the physical risk and resilience tool, this is the neatest part about this. I actually donate my time. I don't get paid by OS Climate. I actually sold my company. And I feel very passionate about what's going to happen. And if we don't have the right data and right information, it could be tragic. So the physical risk and resilience tool is actually built by BNP Paribas. And they have 8 people building this tool to identify the risks of their assets. But they determined that it's not a core competency for the bank, and that if they actually take all of the code and they make it available to the open source community, other organizations will move faster in identifying their overall risks and understanding the mitigation strategies that they can take, right? So they've open sourced it. All of this is available, and there's links at the end in GitHub. You can actually take that tool that you see. It is free and open, and you can just download it and take it and reuse it. Or every Tuesday at 9:30, there is a call between all of the collaborators on how we actually move forward and help build this tool out better. Witness is a transition scenario tool that was actually built by Airbus. Airbus they had 15 people working for 2 years on this. They finished it, and it's not a core competency of building planes. And they said, look, we moved fast. There's lots of organizations who aren't. We'll open source it and give it away for free to everybody else. So I'm actually leading a project to try and take that transition tool and make it available to everybody else. They were focused on aluminum and airline stuff. I was in Egypt and spent some time with Cargill, who's starting to build their transition risk tool. And they said, well, we're focused on all of these other things, and we were just starting. We said, stop, don't start. Actually jump in. We've actually got a tool for you, and just collaborate. And if you can collaborate, we can actually make it available to the world and move much faster. Excuse me. There's a portfolio alignment tool, and there's a big group within our organizations that's very focused on finance and trying to move the dollars that people are spending away from oil and gas and other things to a low carbon world. This tool is actually built to put portfolios in to understand how your portfolio is aligned to those goals. So here are some of the overall links to that. The architecture, so we're here because we run everything on Amazon, although Google and Microsoft are big partners of ours as well, but actually we run everything on Amazon right now. Ultimately, again, the answer is in the data. We're making all this data available to you, and we really need to answer, certain questions on how to slow biodiversity loss, how to improve food security, how to solve the problems of Nigeria, and it's just one, and it will spread. And the final question that I have for you in all of this is one to go back to that causal effect. How did the French Revolution, or why did the French Revolution start? People don't actually really know. People were starving, and there's a famous line of "let them eat cake," right? The fact is, a volcano erupted in Iceland. It put ash in the air. The ash killed all the crops, and there wasn't enough food. And at the end of the day, the food was taken by the royals and the rich, and they didn't have a political structure to vote them out, but they revolted. right? So a climate crisis caused the revolution, right? Let's make sure history doesn't repeat itself on all of this. So again, the answer's in the data, and if people are informed, they can make better decisions. So we need your help of collaborators for organizations who are working in this area. Please feel free to email me directly, and I'm excited to try and get more people involved in understanding what the data is telling. And I know Chris is going to come out in a second, but I will give you one last story. The data is telling stories that my wife says, stop talking, right? Stop talking. But if you don't know what tragedy is in front of you, you can't actually mitigate it. So thank you very much.
Awesome. I'm good. Just take it with you. Yeah,
Thanks.
Perfect. Thanks, Brendan. All right, so I promised some takeaways. But first, I'm going to show you how to get started using open data. So if you go to the Registry of Open Data, and I'll provide the link at the end, I want you to do a search. See where it says search datasets. Let's search on NextRad. You'll see the NextRad registry page show up on the right. If you scroll down, you'll see a purple button. And that purple button is for SageMaker Studio Lab. If you click the purple button, it will attempt to launch SageMaker Studio Lab, which is basically a Jupyter Notebook server. So what is that really? So SageMaker Studio Lab, you don't need an AWS account, and you can use data from the Open Data program. You can use other data that you find in AWS, and you can run 12 hours of CPU or 4 hours of GPU per day for free on this little Jupyter Notebook server. You'll need to create an account, but it's really just to persist your state so you can come back and pick up where you left off. So click the copy to project. Then it will say, do you want to clone the entire repo? Please say yes. Then it will create the Conda environment for you, which pulls in all the libraries, so you don't have to do any of that. And you'll be left at the Jupyter Notebook page. And here, what we have is a Jupyter Notebook that was actually created by a customer a couple of years ago, actually. And it walks you through how to fetch data from the Open Data program using the Bot03 Python library. You can pick some precipitation, and in this case, we're showing an image of Hurricane Matthew from October 2016. And it's all in the library. It's a great place for you to start. If you're curious to start using some NOAA NextRad data or other data sets, there's a bunch of these SageMaker Studio Lab notebooks in there for you to start. It's all open source, so feel free to borrow the code liberally. Links and QR codes, I'm going to end on this slide. I'm just going to leave it here, starting from left to right. The NOAA NOD data in the Open Data program. This will take you to the Registry of Open Data that I just showed you and have the full listing of all the NOAA data sets. The next one is the big data analytics. Adrian talked about that. The cloud journey was so interesting, they wrote a book about it. I bought a copy. I haven't read it yet, but I will. The next link is for the NOAA SBIR program. That's the 50K, 500K small business program that Adrian mentioned. OS Climate has a GitHub repo. Brendan mentioned it. There's a lot of open source code there that's really awesome about climate risk. And last but not least, the NextRad SageMaker Studio Lab that I just talked about. Please fill out a survey. I think my next slide is just a thank you. Here's our contact information, but I'm actually going to leave it on the QR side. So I'll leave it here for a second so you can get our contact information. Please fill out a survey. The surveys are really important to us.